Hello, pre-calc. I am going to do problems number 19, 21, and 22 from your homework, just to show you how you would do that with a normal problem. So the first thing they're asking for is to list all the real zeros and their multiplicity. So for number 19, I've got zeros, multiplicity, and I do recommend that you do this on different paper. Behavior, part A. So x equals 5 is my first one. It has a multiplicity of 1, so it's going to cross through the x-axis. And x equals -2 has a multiplicity of 3. It is also going to cross through the x-axis. And notice I didn't have to worry about this 2 because it's just a constant. It doesn't have an x involved, okay? Where this one, it was an actual x, so that corresponded to x equals 0 for one of my zeros. But if it's just a 2, you don't have to worry about it. It's just a constant. So now, what is the degree of this polynomial? This is x to the first times x to the third, which would give you x to the fourth. So it was going to be a degree 4, and it's going to be a positive lead coefficient. Okay, so positive lead coefficient. Since the degree is even, its end behavior is going to be the same as the end behavior for an x squared function. So something different, it'll be somewhere different, something different here, but the end behavior will be the same, positive infinity on both sides, okay? So when we go to graph this, I'm going to put 1, 2, 3, 4, 5, label that as a 5, and -2, I also have a 0, okay? I know my end behavior is going to be up on both sides, so I just want to remember that. I also know that it's going to cross through, but it is a 4th degree, okay? And so you can put this in your calculator and look at what you get, you know, when you're doing this problem. And it's one of those weird kind of problems because it kind of, it has like a jolted kind of thing over on this side because it is a 4th degree, but it does go through. Now, look at this 3rd degree though. The multiplicity is 3, so remember what I said about that. That is where your concavity is changing. So it does flatten out there at your -2. So that's something to remember. The other thing I always like to find out is what is your y-intercept? So that's another good thing to think about when you're graphing it. Your y-intercept is going to be where your x is 0. So if you put in 0 for x here, you would get 2 times -5 times 2 to the third. So that'd be -10 times 8. So that's going to be -80. So that's really way down here, right? -80. So like I said, it flattens out there, but then it comes all the way down. Crosses through the y-axis. It's on its way. And actually, if you look in your calculator, that y-axis is not even the minimum. You know, it's like goes further. So it looks something like that. It does actually have a minimum here. And I think I calculated it to be 3.250, comma, -506.461. So you do have, you know, a minimum way down there. And they are going to be asking us about concavity intervals. So we do kind of want to know what's happening and where the, I'm looking at my graph and I'm thinking, that really isn't a very good graph, is it? Oh, goodness. You guys need to put this in your calculator because I'm not doing a very good job of drawing this on this. I don't know. I don't know if it's this pen that I'm using, but I do know that the y-intercept is correct. And I also know that, you know, that this is way down there. So maybe I should move this up a little bit and I would have a better time, you know, because we really haven't done anything on the y-axis. So we could pretend like we were, you know, going by tens or something, or even hundreds, I don't know, whatever. If we went by hundreds, if this was like negative 100, negative 200, you know, to get to negative 500 or something, this negative 80 would be further up, but whatever. Go by 20s, I don't know. But anyway, so here is my graph where it just kind of keeps going down and then goes through and then eventually goes like that. I think that might be a better, because you've got concave up from negative infinity to negative 2. Then you have to find your halfway point here. That's why, you know, your halfway point is about right there. That's going to be your point of inflection for when you go to look at, and it's going to be from your negative 2 comma 0 to this 3.25 comma negative 506. So to find that point of inflection, you're going to have to add negative 2. So let's show you what that point of inflection is going to, how we're going to find it. We're going to say, we're going to take our x of the one plus the x of the other and divide by 2. We're going to take the y of the one plus the y of the other and divide by 2. Okay. And so that point of inflection should be 0.625 comma negative 253.231. So do you see how it's just, you know, it's past, it's in between 0 and 1 on the x-axis, this point of inflection, but it's at negative 253. So, you know, it's not as close to this negative 80 as what it looks like, okay, the way I've got this drawn. So, again, I just have not done a really good, oh no, I have not done a really good drawing of this. So let's put my negative 80 there. Let's try that. And this goes down, maybe. That looks better. So then you can see you've got your concave up in purple. We'll put concave up in purple. And then from this point of inflection, you've got concave up again for the rest of the time. Okay, and then in pink, we're going to do, look at concave down. And do you see how it's from this change, where it's to the third power, to your point of inflection? That's your concave down interval. So for part D of this number 19, your concave up intervals, negative infinity to negative 2, and then also, since this point of inflection is at 0.625, comma infinity, and then your concave down interval is just from -2 to 0.625. So you're using the x's to say where they are, okay? So that was your part D. How many turning points? That was part C. We didn't really touch on the number of turning points, but it's going to be one less than your degree. So since our degree is 4 for number 19, it's going to be 3. Okay, so that's the maximum number of turning points. And then I'm trying to think. I think that was all that they asked you to do. Okay, so that, we struggled with the graph on that one, but hopefully I did okay in the end. So that was 19. That was our A. Our B was just this part. Our C was 3 turning points, and our D was our concavity intervals after we found our point of inflection. And we probably should have said that this right here, make it a different color, was our point of inflection. And it should have been halfway between this and this, okay? Okay, number 21. For that one, your zeros, multiplicity, behavior. This is our part A, this is our part B. So x equals negative square root of 2, and x equals 6. Negative square root of 2 has a multiplicity of 1. 6 has a multiplicity of 2. This one's going to cross at x equals negative square root of 2, and this one is going to bounce or just touch the x-axis at x equals 6. So there's your part A, your part B. If we look at the degree of this number 21, we can see that's x to the first times x to the second, so that's going to be x to the third. So is it a third degree? And so for part C, the number of turning points is going to be 1 less than that degree, so it's going to be 2. So now we're going to get our graph ready. And square root of 2 is like 1.4, right? So we've got 1, 2, negative 1, negative 2. So negative square root of 2 is going to be like negative 1.4. I don't know, I'm just going to put negative square root of 2 right there. And then 1, 2, 3, 4, 5, 6. There's our other 0. Now, it's a third degree with a positive lead coefficient, so it is going to have the same end behavior as a third degree positive lead coefficient, like that. So it's going to be different in the middle, but the end behavior is going to be the same as x cubed. So we know it's going to be going up here, and it's going to be going down over here. Okay, so that's a good place to start when you're going to get ready to do all your things. You also should consider your y-intercept, and that is always where your x is 0. So if I put 0 in, I would get square root of 2 times negative 6 squared. So I would get the square root of 2 times 36. So 36 root 2. For your y-intercept. I'm trying to get my light to turn on because I can't see. So this is about 50.912, okay? Just so you know that that is, so way up here, I'm gonna say 36 root 2 is gonna be where it crosses the y-axis. Okay, so now, we are going to need like a little sketch of this. And I did this on graph paper. I knew that it was going through, it was crossing through at the negative square root of 2. I don't know if you can still see that, but it's crossing there. And so I know that this is going up and it's going to cross through. I know it also is going to be going through here somehow. I mean, it might not look like that exactly, but when I put this in my calculator, I saw that it had a maximum here. And I've already kind of screwed it up. I think that I'm going to have to make this taller, because what it does is it goes up and then comes back down like this. And then it bounces, right? And then it goes up like that. Okay, so it looks like that. And there's a maximum here. If you put it in your calculator and you calculate the maximum, it's at 1.057, comma, 60.380. So that kind of looks like a little bit better than what it did. And make sure that this is, you know, smooth. You don't want it to be, oh gosh, darn it. I didn't want to do that. You want this to be nice and smooth, like that. Okay. You don't want it to come as a, like a V shaped by the 6. Okay, so there's your function. And it has a relative min of 0 at x equals 6. So you can see this is your minimum at 6, 0. And it has a relative max of 60.380 at x is approximately 1.057. Okay? So you can see that in between your max and min, that's where your point of inflection is going to be located. And so we're going to calculate that point of inflection. We're going to take our 1.057 plus 6 divided by 2, and we're going to take our 60.380 plus 0 divided by 2. And that's going to give us a point of inflection 3.529, comma, 30.19. Okay, so this is your point of inflection here. This is going to be where concavity changes, and we're saying that it's at 3.529. So my graph's not too bad, but that tells me that we have concave down for all of that. That's all concave down. And then concave up here. So if I was going to give concavity intervals, concave down from negative infinity to 3.529. Oops, sorry. And concave up from 3.529 to infinity. Okay, so there's your part D for number 21. Number 22. Zeros, multiplicity, behavior. We've got x equals 0, multiplicity of 1, that's right there. So it's going to cross. And we've got x equals plus or minus the square root of 5. I'm just thinking, I wish I would have left some more space. Sorry about that. So positive square root of 5 and negative square root of 5 here. And both of those just are 1, because what you would do on this one, if you had your f of x equals 3x times x squared minus 5, you're going to think of it as, oh, well, I could actually make that x minus the square root of 5 times x plus the square root of 5. So those end up being linear then, because they're x to the first power, where this is a quadratic. And so once they're like that, then they have a multiplicity of 1. So they are going to cross for both of those. So there's your A, there's your B. The total is degree of 3. So for part C, number of turning points. And again, this is number 22, sorry. Does not like me today. There we go. 2. Okay. And we'll go ahead and get ready to draw a picture of it. This one's not bad, again, because, well, this is your negative square root of 5. That's your positive square root of 5. It's symmetrical. It has a positive lead coefficient, so it's going to go, I forgot to put those zeros in. It's going to go up on this side and down on that one, because it's odd with a positive lead coefficient. And they all cross, so you're just going to go. So it's kind of easy to draw. You're going to have a max, you're going to have a min, and since this is symmetrical, your point of inflection is actually going to be 0, 0. So this one is super easy. But let's go ahead and calculate it. If you calculated your max here, so we've got a relative max at negative 1.291, comma 12.910, and a relative min at 1.291, comma negative 12.910. So it's very symmetrical. And so if I wanted to find my point of inflection, I would add my negative 1.291 and my positive 1.291 and divide by 2. I would add my 12.910 and my negative 12.910 and divide by 2. So you can see that your point of inflection becomes 0, 0. And so that makes it nice because you can see that your concave down here and your concave up here. There's your concave up. So if you were writing your concavity intervals, concave down, negative infinity to 0, concave up, 0 to infinity. Okay? And that is your 19, 21, and 22.